All right, we're continuing on with our discussions of surface area. We already covered the prisms over the last couple of days. Today we're going to look at the surface area of pyramids and cones. Okay, now finding the surface area of pyramids and cones is slightly different than it was with prisms. Pyramids and cones have more things in common with each other than prisms did. Okay, since they have these things in common with each other, it's going to make it a little bit easier for us as far as not having to go through and look at nets and figure out all the different shapes and all the different formulas that go with those shapes, and then working out all those areas and adding them all together. Okay, when it comes down to the figures that only have one base, you're going to have formulas that go with them. Okay, but just like a lot of other things in geometry, it's a good news, bad news situation. Yes, you get formulas, that makes it a little easier, but yeah, that's going to make the problems a little harder. You're going to have to do some solving for some missing information that the formulas need, stuff like that. Okay, here is the primary formula, or formulas, if you want to term it that we're going to be working with for the surface area of the figures that only have one base. Now it's the same formula twice. I give it to you twice because I am not sure which version of it you're going to see on your formula charts. It will either be 1/2 PS plus big B or 1/2 PL plus big B. And the only difference between the two is a language difference, and I kind of hinted at this when we were talking about the different vocabulary. Some people call that distance that comes down the outside of the figure, sometimes it's called a slant height. Okay, other times it's called a lateral height. So whether they call it slant height or lateral height, whatever. Okay, they are synonyms. They mean the same thing. Okay, I just don't know which formula you're going to end up seeing, so we're gonna make sure we see them both. Okay, 1/2 PS or 1/2 PL plus big B. Little p represents the perimeter of the base of your figure. Okay, so if we are dealing with a pyramid, then we're going to get a polygon of some kind that we'll have to find the perimeter of. Or if we're dealing with a cone, then we're going to have a circle on our base. We'll have to find the circumference. Okay, that's what P is going to be about. Obviously, we've already talked about S and L. Those are slant height or lateral height, whichever vocabulary happens to show up. And big B, okay, big B is your area of your base. Now, one slight little language thing here, anytime you notice on tax or star, if a formula comes across with a capital letter in a formula, then that capital letter is always referring to the base. Like sometimes you'll see a capital P. What's capital P going to be? Well, since it's capital, it's referring to the base, and P is going to be perimeter of the base. Capital B, since it's capital, it's referring to the area, to the base, and in this case, big B, area of the base. Okay, so a little bit of language there. Okay. And one thing that does make our lives a little bit easier when it comes down to working with the pyramids is all the pyramids that we're going to see are going to have regular polygons for their bases, unless we come across some strange problem and that problem does say, oh, by the way, the base is a rectangle or a trapezoid or something like that. Okay, so regular polygons, so we're going to get squares underneath our pyramids. We're going to get regular pentagons, regular hexagons, regular octagons, stuff like that. And that formula stays the same, 1/2 times the apothem times the perimeter. Okay, so that's the way that this is going to work. All right, so let's take a look at some examples, see if we can put these this formula into action. Okay. I know we're not artists. Do the best that you can to scribble down the diagram, or at the very least, just follow along with us. As with any problem that ever requires a formula at all, Okay. Hopefully you will be able to look at the problem. You'll be able to identify that there is a formula that's going to be needed. And then I want you to transfer the formula onto your paper. Okay, whether it's a formula that's in your brain or a formula that's on the formula chart, write it down on the paper. Find the surface area of the rectangular pyramid shown below. So we go, okay, yeah, pyramid, surface area of a pyramid. We got a formula that goes with that. That's that guy, and we'll get it off the formula chart. 1/2 PS plus big B, or 1/2 PL plus big B, whatever formula they happen to give you. Now, obviously, in the formula, there's 3 unknowns that we're going to have to figure out. We're going to have to know the perimeter of the base, we're going to have to know the slant height or the lateral height, and we're going to have to figure out the area of the base. So probably a good first thing to do is to scan the figure and start figuring out where are spots that we are going to have to solve for. Okay, well, let's think about the perimeter of the base real quick. Do we have enough information to find the perimeter of the base? Yeah. Okay. And they said they called it a rectangular pyramid, but that's one of the things I kind of warned you about at the end of last week. They will use this word rectangular when it comes down to solids, but when they say rectangular, what they're saying is square. Okay, that the base of this figure is a rectangle, but more specifically, it's a square. So yeah, we've got the perimeter of that square underneath that pyramid. That's going to be very easy. Okay, how about slant height? Do we have the slant height or the lateral height? Not the lateral. Yeah, we've got 12, which is the height. Okay, the regular height. Okay, so I think that slant height or lateral height is going to be one that we're going to have to work on. Okay, how about the area of the base? You think you have enough information to find the area of the base? It's just a square, right? All you need in order to find the area of a square, I mean, the area formula is side squared. We've got a side length. We'll be able to find area of the base. So slant height is going to be the one that's going to bring us a little bit of trouble, if there's any trouble at all. Okay, so let's figure them out here. Little p, okay, perimeter of the base. How are we going to find the perimeter of the base? Add them up, okay? It's a square, okay? All of the sides are going to be the same. We've got 10 units on one side, 4 sides on it, obviously 4 times 10. Our perimeter of our base is going to be 40. No big deal. That's just a number that's going to eventually get plugged into our formula. Okay, now that brings us to the slant height. Now that's the one we said that we're probably going to have to do a little bit of figuring on. Okay, but remember, okay, finding area of polygons is going to work the same as it's kind of going to work when we're finding missing information with our solids. Okay, if we're missing a piece of information that we need to have in order to proceed, then chances are our best strategy is to set up a right triangle that uses the piece of information that we're trying to find and see if something like Pythagorean Theorem or possibly SOHCAHTOA might be able to come rescue us. Okay, so what I did is I looked at the figure and decided, okay, is there a triangle that can be set up in there that would attach itself to the slant height or the lateral height? And yeah, using the height and the apothem inside of that base, you can see you've got that red triangle built in there. Now, how did I know that the apothem was going to be 5 inside of there? Yeah, simply speaking, it's half of the base, half of the side of the base. Okay, so the 12 on the height was provided for us. The 5 was easy enough because we knew the entire side length of 10. And, well, there's your lateral height sitting out there. Okay, so we've got enough information to do Pythagorean theorem. Okay, so what's the hypotenuse in this particular instance? 12? Yeah, we're missing the hypotenuse this time, right? Okay, that's what our goal is going to be. So we're going to get 12 squared and 5 squared. Those are going to be our legs. And we know that those are the legs because those are the two that are perpendicular. They build the right angle. Okay, so let's check it out. And some of you may already know this answer because you may have already memorized this triangle. Okay, 12 squared is 144, 5 squared is 25. 144 plus 25 is 169. Okay, we take the square root of both sides. Anybody know offhand what's the square root of 169? It's 13. Okay, 13. Okay, this is one of the, what is this kind of triangle called when you have all three sides and they're all three whole numbers? Pythagorean triple. This is the second of the Pythagorean triples that shows up, the 5, 12, 13. We'll see it quite a bit. Okay, but there you go. There's your slant height or your lateral height, whatever you want to call it. Okay, and there you go. It's just a value. It's going to get plugged into the surface area formula once we get all of our information figured out. That leaves us with only one piece of information left to find, and that is the area of the base. Okay, so area of the base, no biggie. It's a square, side squared. Okay. Well, how long was the side of our base? It was 10. Okay, and 10 squared, how big is that guy? Okay, it's 100. There you go. Okay, pretty simple math. Okay, pretty simple math. Those are the three variables that we needed to find. We needed to find the perimeter of the base, we needed to find the slant height, we needed to find the area of the base. We have found all three. Now there is nothing to stop us from going back to the area formula, the surface area formula, plugging in the values and simply finding out what number this is. Okay. 1/2 is part of the formula. It's going to be there. Perimeter of the base, I believe we discovered that was 40. Slant height, I believe we discovered that was 13. Area of the base, we just discovered that was 100. Okay, so all we're doing is plugging in. Follow your order of operations, do your multiplication before you do your addition. Okay, let's see if we can figure this out. Half of 40 is 20, and 20 times 13. Well, 2 times 13 is 26, plus that extra 0. Okay, it's going to be 260, and then plus 100. Okay, and 260 plus 100 is very obviously 360. And if there were any units provided for us, which there were not in this case, it would have been whatever they are squared. Square inches, square feet, square miles, whatever. Okay, that is how this formula works. So that's how it works. The only thing that can happen to you at this point in time is they're going to change figures on you, they're going to change missing information on you, and you will have to adjust according to getting the information into the formula. So let's have a look at another one. Find the surface area of the triangular pyramid shown below. All right, well, once again, hopefully from the problem or the instructions in the problem, you can identify that, yes, it's a surface area question, and yes, it is a figure that has only one base. Then you can go to your formula chart, and you can pull the formula off the formula chart, put it down on your paper, so we can use it. Okay. Not a bad idea, as always, to start off and just kind of take a quick survey, get some inventory, decide which of these values is already provided for us, and possibly which of these values we're going to have to calculate. Okay, let's just start off. Perimeter of the base. Have they given us enough information to figure out the perimeter of the base? Okay. All right, sounds like we may not be sure. Okay, now technically they probably should have identified for us which of these triangles is the base. Okay, but if you run into a situation like that where they don't really identify it for you, and you've got triangles all over the place like this, probably a safe assumption to assume that it's sitting on the base this time. Okay, so have a look at the base. Can we figure out the perimeter of the base based upon what we've got? Yeah, we can, okay, because we said our triangles, our bases of our triangle, our pyramids are going to be regular. So if we've got 6 along one side of our base, it's going to be 6 traveling around the other sides as well. So perimeter's not such a big deal. How about slant height? Okay, did they provide us with slant height this time? Yes, they did. Slant height was given to us. That was nice of them. Okay, and how about big B, area of the base? And it looks like we're probably going to have to stop and do some figuring on this one. We're probably going to be missing some of the information that the area of that triangle formula is going to want. But we'll deal with that when we get to it. Okay, so let's come back. Perimeter of the base. What's the perimeter of the base going to be in this case? 18. Pretty simple. You've got 3 sides, and each of them is 6. So 18 is a pretty easy number to arrive at for your perimeter of your base. Okay, slant height. Well, slant height was just as easy as reading it straight out of the picture in this case, which would have been how much? Yeah, 5. Handed to us in the picture. Easy. Okay. Area of the base. Okay, we said that this is probably where we would have some trouble, so let's take a look at it. Okay. Now there's a triangle, obviously. It's a triangular pyramid. So our area formula for any triangle is 1/2 times base times height. Okay. So let's have a look. I took that triangle out of the base of that rectangle and just kind of drew it again. And that's not a bad strategy, especially if you're one of the people that your brain gets kind of jumbled up when you're looking in these pictures and you can't really keep it straight in your head what's what. Maybe not a bad idea just to redraw that base so you can have a look at it. Okay, so I took that triangle out. Okay, we knew that one of the sides was 6, but we also understand that the triangle is regular, so that's going to cause 6s on all the sides, which is how we were able to find our perimeter. Now, there was a dotted line going across the base, okay, that was unknown to us, okay, and I drew that one in here as well, and that's our height, okay. Our base and our height are going to be perpendicular to each other, so it's very clear to see that we're going to use 6 as a base, and we've got to figure out that guy. Now, any thoughts on how you're going to figure that thing out? Pythagorean theorem, right? Okay. There are 2 little triangles inside of this guy. Do you know 2 sides of these little triangles and can define the third? Yeah, well, obviously we got the hypotenuse on either the left side or the right side, whichever one we choose to use. Yeah, that guy across the middle, that height in there, obviously is going to be our variable. And the other sides, as already been said, are going to be 3 because that altitude is going to come down. It's going to split that base or that side in half. So we got a 3. And in this case, it's one of the legs that's missing, one of the guys that forms the right angle. So we've got a 3 as a leg, we've got a 6 as a hypotenuse, and we just need to finish this thing off. What's 3 squared? 9, and 6 squared? 36. Okay, so we got 9 plus x squared, or h squared equals 36. We'll subtract the 9 to the other side so we can have the h squareds by themselves. That leaves 27. But of course we don't want h squared. We just want h. So we'll take the square root of both sides. Okay. And if you're working on an ACT or an SAT, you would leave that as a radical. That would be 3 square root of 3. Okay, when you simplify the square root of 27. If you're working on tax or star, it's okay to go ahead and go to a decimal point and continue on. Okay, so the square root of 27 is in the ballpark of 5.20. Okay, now that's great. That's not an answer to anything except for what was the height of our base. We stopped working on the surface area problem because we could not get past the area of the base question. This number, 5.20, was needed in the formula for the area of a triangle. Okay, so we're still working on the area of this base. We need to take this number, we need to plug it into our formula for area of a triangle right back here, along with our base information, which was 6. Okay, so we're still working on the area formula for the base, 1/2 times base times height. But now we have all the information that was needed to work that formula. Okay, so 1/2 times 6 times 5.20 ends up being, when you don't dump off any of the decimals, it ends up coming out pretty in the area of 15.59. Okay. Now, be a very easy opportunity to accidentally quit on this problem too early because you just calculated an area. But did you find the surface area of the solid? No, we just found the area of the solid's base. We still have to work the surface area equation, 1/2 times perimeter times slant height, plus the area of the base. Okay, so that's always one of the questions we ask before we give up on a question or before we answer a question. Did I answer the question that they asked? And we haven't answered that yet. Okay, now plugging in information, perimeter to the base, if I remember correctly, the perimeter was 18. Slant height, if I remember correctly, the slant height was 5. And the area of the base we just figured out is in the ballpark of 15.59. Okay, so plugging everything in that we found out, All we have to do is probably go to our calculator on this and figure out what this is going to be. Half of 18 is 9, times 5 is 45. And 45 plus 15.59 is probably 60.59. And there you go. Whatever the units are, inches, centimeters, millimeters, squared. All right, there's only one more shape I want to look at, and you probably know what it is already. It's the cone. As I told you yesterday or the day before, whichever day it was that we got to cover the surface area of the prisms, told you can probably expect the tendency is when they ask volume and surface area questions that they like to get the circular bases in there. Okay, so it's very likely that you will see a cylinder or a cone of some kind, and possibly even another shape that does not have a circular base, but they do like to ask questions about the ones with circular bases. So let's have a look. Okay, find the surface area of the cone shown below. Well, once again, this is a pyramid. It just happens to have a circular base, which is why we call it a cone. Okay, but it is still a pyramid. That means the formula for the surface area of a pyramid does still apply. 1/2 times PS plus B. Okay. So again, let's take inventory real quick. Let's see if we have the required information to fill in this formula. Perimeter of the base. Okay. Well, our base is a circle. So we're thinking circumference, okay, really instead of perimeter. And we have a formula for circumference. It's 2 pi r. Okay, so all we need to know to find the circumference of a circle is the radius of the circle. Do we know that? Yeah, we do. I mean, they didn't hand it to us, but it can be easily found, right? Okay, how about the slant height? They give slant height to us? No, no slant height this time, so we're probably going to have to calculate that. And big B, area of the base. Well, again, our base is a circle. How do you find the area of a circle? Pi r squared. Okay, so we're going to need radius, and we've already discussed that, yes, we've got the radius very easily. Okay, so slant height's going to take a little work. The rest of this will be pretty much just plugging into formulas and getting answers pretty simply. So perimeter of the base, okay, it's a circle, 2 pi r, and I know some of you learned it as pi d back in the day. That's fine either way. Actually, pi d would be a little bit more convenient in this case because they did hand us the diameter. Okay, but in either case, whether you want to multiply 2 times 12 or whether you want to go ahead and just use the 24 that they gave you, either way, we're going to our calculator and we're going to multiply 24 times 3.14. And in this case, we get a value that's in the ballpark of 75.4. All right, slant height. We already said slant height was going to be an issue. Okay, so it shouldn't be a big surprise, but we're going to follow the same strategy we've been following for 3 or 4 weeks now. We're going to see if we can't build ourselves a triangle that will attach itself to the slant height, and then see if we can do Pythagorean Theorem on the way out of there. Well, glancing back at the cone real quick, okay, we do have the height inside of the center of the cone, even though they marked it on the outside. Okay, the overall height's 30. How about the distance coming across if we build the triangle through here? Okay, what's the radius inside of there? 12. Okay, and the slant height is going to be our hypotenuse. Okay, well, we got some bigger numbers to work with here. Okay, probably big enough that some people would be uncomfortable with them. Hopefully, we know that 12 squared is 144. 30 squared is 900. 144 plus 900 is 1044. That equals s squared, but of course we don't want s squared, we want s, so we'll take the square root of both sides, and we'll end up with something in the ballpark of 32.31. Okay, it's just a number. We'll hold on to it because it's going to get plugged into our surface area formula later on. That leaves us only one variable to solve for. That's the area of the base. Okay. Our base is a circle, and as we said, we find the area of a circle with pi r squared. And as we already know, the radius of this particular circle was 12. Okay, well, there's 12 squared again. So we've got 144 times pi. and that comes out being 452.40 or somewhere around there. And it's just the same process over and over again, solving for the little pieces of missing information and then plugging into the formula. 1/2 times 75.4 times 32.1 plus 452.4, the results of all the little calculations we've been doing. And in this case, the surface area is 1,670.49, whatever the units were, squared. Okay. That is it. It is using this formula over and over and over again. Okay. So we have some problems to practice. So please let's take a look at those.